Hi, my name is Kelsey Williams, and I'm a student in Professor Smith's Civil Engineering Techniques course for the 2016 fall semester. This video serves as a description brief of my design ideas on the open space between Thornton Hall D and E wings. The first design plan represents the existing conditions of the site. My project group and I field surveyed the site in early November, so all of our data points are recently accurate. We made sure to include plenty of data points that specifically captured the change in elevation. And to briefly describe what the site looks like outside of this design plan sheet, the Grass Thornton area is essentially a large hill, and gradually the slope of the terrain declines, and further outside of our site boundaries is where the hill really dips into a lower elevation, almost like a trench between the bottom of the hill and the front of Thornton E-Wing. And going back to the design, the green outline figure is the established surface model created after uploading the points into AutoCAD, and I was able to create the surface contour lines with specified elevations, and there was a range of about 544 to 548 feet in elevation. Moving on to the next design sheet, I want to focus on the implementation of the 2,000 plus square foot pad. Outlined in yellow is a quadrilateral figure representing the pad, and my material of choice would be concrete. So where the pad is located in relation to the entire space between D and E wings is just at the top of the hill, sort of right when the hill begins to drop off. And I plan to level the land beneath the pad so it sits on a flat surface, and this way any precipitation will just run off the pad and down the hillside. So as for my proposed stormwater design, this last design sheet is what that focuses on. There is a lot going on in this design right now, but please focus on the blue water flow lines, which represent the direction and flow of water throughout the surface, and the catchment areas around the surface. However, I did decide to implement an infiltration basin at the bottom of the hill outside of the proposed boundaries. The water will run off the hillside, trailing down into the trench, and the basin will be below to capture and harvest the water as a shallow pond. And this way, flooding and water erosion can be prevented. In addition, I designed the basin above a water pipe, which will need to be cut back, but near enough so that it can drain water and transfer water from the pond when it does overflow. That is the end of this project video brief. Again, my name is Kelsey Williams, a student in Professor Smith's Civil Engineering Techniques course, and I thank you for listening to my project.